Good morning. Good morning, everyone. Hope you're all well and enjoyed the coronation weekend. We have a really interesting and I think exciting topic that we're going to talk about today, which is about how security is being transformed by AI and ML. And talk a little bit about the ethical concerns, the limitation of using these new technology. And we've got a really knowledgeable subject matter expert to talk to us about this today, Alessandro Magnosi, who's been a security consultant for over 10 years now. And he's currently a member of the security testing team at BSI. And actually on his LinkedIn, he loves bug hunting. So then you'll know where to go if that's what you're looking for. So I'm Maggie Titmuss. I've known Martin and the SASIG gang for quite a number of years now. It says I'm a director advisor consultant. That's after a full career in law enforcement, 5 years in the finance sector, and now I have a small portfolio of companies that are either startups or others that I advise. And today's topic, as I say, is really interesting because you've read over the last couple of weeks about, is this going to be the thing that transforms everything that we do, or is it going to be the end of the universe as we know it? So I'm really interested in seeing where it takes us. But in case you're like a lot of us who don't know a huge amount about the topic, SASIG are putting together a webinar on AI and ML and how to use it. And there's also going to be an in-person event on the 23rd of November in London, which is going to explore the topic more fully. So very quickly canter through the house rules, etc. Just want a big thank you for all of our supporters because SASIG couldn't do this without you. We've got a slide that covers webinars that we have over the next few weeks. How the first one is how the England's Patient Safety Commissioner is improving the safety of medicine and healthcare through cultural change, which I think that'd be through culture change, which I think would be interesting. The next one is how do you get everybody on board when it comes to preventing, responding to cyber attacks against modern vehicles. Third one about the war in Europe changing the threat landscape. I think that's going to be an interesting one about shifting the popularity of intrusion vectors. And then the last one, 50 years of computing, comms and security. Look back, learn and chuckle, because actually if you think about it, you've got one man's unique and entertaining 54 years of doing this. So we've got some upcoming events in person. We've got one in Liverpool, Guildford, Edinburgh, and then London again in terms of a thought leadership summit. All of those in person, please just apply, that's fantastic. And then we've got the big SASIG on Thursday, the 18th of May in central London. The platform is now open for you to book one-to-one meetings and have a fantastic time. I think there's over 300 people due to attend, so really phenomenal. Next one is how do you get hold of SASIG on social media? And then we've got our house rules as usual. We can't strictly enforce Chatham House rule, but please respect the speakers and questioners. We're going to have an opportunity for Q&A at the end. And because I think this is a really interesting topic, if we don't have enough time to take all of the questions, what we'll do is we will take those and Alessandro will look at those after that. So if I can now please hand over to Alessandro, welcome, and look forward to hearing what you have to say.
All right, let's crack on then. Let me check if I can also share my audio. I think yes. Okay, so let's see. Can you see the slides?
Yes, we can. Thank you.
Okay, perfect. So thanks a lot for joining. Thanks a lot for joining this talk, and thanks a lot, Maggie, for presenting it. So this talk will be on an exploration that we will do all together on the impact of AI and ML in cybersecurity. Before starting, I'm Alessandro Magnosi. I'm known as Virus on GitHub and Twitter. I work as a principal security consultant for BSI, as Maggie already said. And on night, I'm an independent developer and bug bounty hunter. You can reach me out on LinkedIn as Alessandro Magnosi, or on Twitter or GitHub as Glassvirus if you have any question about anything that you will see in this talk. Okay, the agenda, let's see what we will see. So we will start by giving a sort of overview for anyone that is not really familiar with the terms AI, with the terms ML. We will give a bit of history about what it is and why we use it. Then we will analyze a bit the models that are mostly used in AI and ML to solve problems, and specifically we will see how they are applied to solve the most common problems in cybersecurity. Of course, given the high amount of visibility that tools like ChatGPT and other transformer model-based architecture has gained in this time, we will also see ChatGPT a bit and how this can be used for improving your cybersecurity pipeline, or to be, and actually how can it be abused to achieve not really ethical goals. And at the end, we will try to give some answer on how we can lead the way for smarter cybersecurity by also minimizing the risks a bit. So let's start with common terms like AI, ML. So I think you've seen something like this a lot in like on internet, in other talks. And we usually use AI and ML interchangeably, and there is a reason for that, of course. AI is because, and it's because ML is a subset of AI. So AI is, in general, that field of study that tries to build machines that can solve problems that usually require a human mind to solve. While machine learning is a subset of it, that instead is focusing on generating the algorithms and giving them to AI models. And these algorithms are meant for a machine to automatically learn how to solve a specific set of problems without actually requiring a programmer to actually instruct the machine to solve them. And this, of course, is incredible because you obtain a huge flexibility and you can solve a huge class of problems. And the solution that you usually find using these methods are more resistant to small changes and perturbation of the problem you're trying to solve. And there is another term that we also use usually when talking about ML, and it's deep learning, DL. And deep learning is indeed a subset of machine learning that uses extensively deep neural networks to solve problems. And that is the main definition. Is like, I would like to spend like a few seconds on the history, because when now we are hearing a lot about AI, but is this really a new term? And indeed it's not. I mean, we've seen the start of AI potentially in the 50s. And if you think about that, Turing invented the Turing test, which is used to distinguish between machine and human in the 50s. And in 57, a psychologist actually formulated and created the first example that we have of perceptron, which is the basic unit of a neural network. So it's not a new topic at all. In the 60s, we have early AI systems and general problem solvers. In this period, we see that the main implementation of these systems is through rule-based systems that can emulate an expert in specific areas, specific topics. Then in the 80s, 90s, oh, there is 2013, it's completely wrong. In the 80s, 90s, I'm sorry for that. In the 80s, 90s, we started shifting from rule-based system to actually starting creating algorithms that can automatically learn from data. And so we actually started developing things like supervector machines, we will see them later, or decision trees, and even neural networks. Actually, in this period, I think 85, because I think that the first formal definition of continuous backpropagation, which is one of the main systems used in deep networks, in deep neural networks was actually formulated in the 60s, but it has not actually been used or useful until the 80s, so 85, around 1985. And then in the 2000s, so more recently, third millennium, we started seeing how to use deep learning models more and more. And in 2009, we have an evolution. We have ImageNet, which was one of the biggest and most effective networks for image recognition using deep neural networks. And then we have AlexNet in 2012. And after 2010, we have a lot of incredible evolution of deep learning. And then finally in 2016, 2017, with the paper Attention is All You Need, the transformer model was introduced. And the transformer model is what practically all large language models are now based upon. So GPT, which is a decoder-only model, is based on the transformer model, or the transformer architecture, but also Lambda from Google, BART, etc. And now in after 2020, so 2022, 2023, we have GPT-3, GPT-4 with ChatGPT, Lambda 2 and BART from Google, and we have other models like OPT, Bloom, and a lot of others models, all based on the transformer architecture. So, but what are the most famous? So let's give you just a brief overview about all the models that are used in machine learning. As we've said, I mean, models and application of machine learning. And as we've said, machine learning now is applied to everything. Like before ChatGPT was released, AI was already applied in a lot of fields without us realizing. The impact of ChatGPT was probably let us realize how much we use AI nowadays to solve problems. And one of the main problems solved was image recognition, but also speech recognition, natural language processing, recommendation system, which is what you use commonly when you are on Netflix, Amazon Prime, and you have a suggestion about some content. And this is exactly what a recommendation system is. And it's using, under the hood, it's using an AI model. It's doing some clustering of the data that you usually see. It accumulates with other people that are watching your same things, and it just recommend a content which is similar to what you like. Strategic decision-making, or autonomous system. I think everyone now is watching the improvement of, auto-driving taxis or Tesla autonomous system, except some big incident happening, but except for short and some errors, is going pretty well. I mean, we can do nowadays things that a few years ago were completely impossible, and this is actually thanks to the evolution of AI. And when we talk about AI, we usually differentiate between three main models of AI. For the technical people, you will see that there is no self-supervising. It's because I'm classifying it as unsupervised learning. So self-supervised and unsupervised learning are a bit different, but I will, for the sake of simplicity, I will accumulate them. So supervised learning is, so the three types are supervised, unsupervised, and reinforced learning. So supervised learning is a model that is used to let a machine understand, to distinguish data, learning from a labeled data set. So usually there is a pre-processing process that can be done by humans or can be done with another automatic method, but it's not really implemented within the model. And it's used to label data. For example, this image is a cat, this image is not a cat. This is something that in security we use, for example, to implement email filtering. So you have a supervised learning, you have a lot of mails, and you say, this is spam, this is not spam, and the machine will extrapolate features from this data set and will start to accumulate features to spam and other features too. Like based on this feature, we'll start creating a mapping, an internal mapping between what kind of things make a mail spam and what kind of things make a mail legit. And after that is able to classify spam from not spam and predict if the next mail you receive is spam or not, with a certain degree of accuracy. Of course, the more the data, usually, the more precise is the system. Unsupervised learning instead is able to learn from unlabeled data, and usually is actually unsupervised systems are used to extrapolate patterns from unlabeled data to actually identify structures or to generate clusters within unlabeled data. And this is what you use for a customer, for example, to create targeted marketing. For example, you have all your customers, you start generating from all the data on your customers, etc. You start generating and dividing kind of type of customers in clusters, and then you do targeted marketing based on the preferences that your customers have shown in the past. And then you have reinforcement learning, which is completely different paradigm, and it's actually usually implemented by having an agent that doesn't take a data set, but it has a way to communicate with its own environment. So maintaining information through sensors or other ways or other means, by being able to detect, to collect information about the environments, it can start selecting actions to arrive to a certain goal. And usually we use a feedback mechanism to instruct the agent what is a good action and what is not a good action. And based on this feedback, the agent can learn what to do to arrive to a potentially optimal solution. And so we said, except for reinforcement learning model, that are models that are used nowadays in cybersecurity just to emulate testing, or, well, actually there are a lot of uses for that, but we are more interested today in standard machine learning models and deep learning models. So let's discuss a bit what kind of algorithms, what kind of models are actually used. And as we've seen, in machine learning, we have decision trees that, for example, are heavily used or have been heavily used in EDR system and AV system. And these decision trees can actually are hierarchical tree-like structures and are using for classification or regression tasks. But the main thing is that they can divide data based on features. And for example, ADR system generate these decision trees to arrive to an understanding if, for example, an event based on all the data surrounding that particular event should raise an alert or not. Or, for example, you have sub-Roberto machines that instead are used to identify boundaries between classes and are used for classification tasks. And then we have neural networks. Then instead is what we are more interested within today, because of all the interest that was generated by deep learning. Neural network are biologically inspired computational models, and the very good thing about neural networks, and especially of deep neural networks that we will see in a short while, is that they can they are very capable in approximating very complex data patterns within data, and this makes them very flexible, because it means that they can easily approximate an arbitrarily difficult function. And then you have, and in deep learning especially, we indeed have convolutional neural network. There are specialized neural networks that you use a clever combination of convolutional layers and pooling layers to identify hierarchical data within data, within hierarchical structures within data, and have been used extensively in image recognition tasks and object identification tasks, etc. Then we have recurrent neural networks that were the predecessor, like that practically are networks that have been designed to analyze sequential data that is subject to a temporal dependency, like, for example, speech. of course, when we speak, we put a word after the other. So every word has a dependency, a latent dependency with something that we said before. And this networks were what we have been using in the past for machine translation or other stuff on NLP. They showed a problem with vanishing gradient, and after a while we developed a system to actually provide them memory via LSTM, long-term memory, or GRU. But ultimately, we actually, after the transformer model was generated, we actually switched to the transformer model for this kind of task. And then this is not really. And then we have GAN, Generative Adversarial Network. This is an architecture which is quite complex. It has two networks, discriminator and generator. And what you do is that you have a discriminator that acts as an actor critic, and the generator generates sample data based on real data until, and the process and the actor critic will just say, oh, this look fake, this look true, this look fake. And this process is repeated until the generated data is actually can fool the actor critic. So it's really similar to real data, right? And this is a network that is used to generate realistic data samples, of course. And then we have the revolution, like the transformer model that uses a very clever combination, like a very clever architecture, to be honest. And the fun, like the most incredible thing about the transformer is the notion known as self-attention, that used in combination with positional encoding can take, instead of like in contrast with what was done with RNN, that analyze the sequence, the temporal sequence, one token by token. The transformer model just take all the sentence. And by using a combination of this self-attention with positional encodings to sort of remember the position of a specific word in the sentence, it can identify the latent relationship within words within a sentence. And this actually showed that to be very, very effective. And nowadays, all the models that we are currently using for generating code, for generating code or natural language are somehow based on the transformer model. I put BERT and GPT here. This is an image that I put in this URL, and just to define that not all transformer-based architectures are actually full transformers. So GPT is a decoder-only architecture, while the transformer has an encoder that encodes the token of a sentence and will actually generate an intermediate representation of the data that can be exploited for reconstructing and generating something out of it. But the GPT, for example, just using the decoding part of the transformer model, and it's just used for text generation. And GPT in particular is a stacked version, like it has a stack of decoder, and I think that ChatGPT showed us how this kind of architecture is very powerful and can actually generate very realistic data in terms of natural language. Instead, BERT is an encoder-only model. And BERT is by Google, by the way, while the GPT series is by OpenAI. And just to give you a temporal definition, BERT was one of the first models created following the transformer revolution. And then we've seen a lot of models being released. And if you want to keep track of GPT-3, that was released around March 2022. Then we have Lambda 2 around May 2022. And I think not long ago, GPT-4. I didn't put it on the slide, but GPT-4 is probably the last that was released. Okay, that's all great, but how this relates to cybersecurity? How we use this for cybersecurity? Well, I put everything on this well, not really everything. I think that from a defensive perspective, the most usage of AI was, I mean, of course, if you are with me so far, you've understood that it's very easy to take AI to like create a baseline of any data I want to train it upon, right? So, and this is exactly like the mail, like what we said for email filtering, right? So if I want to discern by something that is bad from something that is good, what I need to do is just train a model to recognize the pattern that means bad and the pattern that means good. And for defensive security, this is very powerful because, for example, in anything that goes from phishing detection to anomaly detection to malware detection, this is an approach that I can follow. And this was extensively used, and it is still extensively used by EDR. In terms of anomaly detection, this was used by IPS and IDS system, so intrusion prevention system and intrusion detection system, which is what prevents your systems usually to be attacked from an external network and can identify actually attacks, or even from WAF systems, because they can map what is the normal flow of an application against the server, against the web application, etc. And they can understand if something is exiting the baseline, which is the normal baseline. And this is the same way actually anti-DDoS mechanisms are detecting malicious activity or an attack on the network by actually estimating the type of data and the amount of traffic. And in malware detection is that this is used by exploiting binary features of a specific executable. For example, let's consider Windows for a second, and you want to classify a malware. There are multiple ways to do that, but if you want to apply machine learning over it, you will probably exploit a set of features of the binary, which can be the byte level features like the byte histogram, or the entropy, or other binary features, or you can actually use high-level features like the function imported by the function present in the import table, or the section names, or similar kind of detection. And this can be extended to dynamic analysis, where you can analyze the call API sequence, for example, and classify the behavior of a malware by actually understanding what kind of APIs the binary is calling at a given time. And if you have a baseline of Banyan executable, and you have a collection of malwares, you can easily classify the next binary you see as malware of Banyan based on all these feature set. Of course, this can be used and is very useful to do in threat intelligence. When I call threat intelligence, is a bit an abuse of terminology here, because, for example, I include in this the vulnerability prediction. What is vulnerability prediction? Well, all the things that goes from vulnerability assessment to code scanning are vulnerability prediction systems. Like you can actually understand and identify a vulnerability before this is happening. And as a lot of you can know, this is not really threat intelligence. Threat intelligence is more about getting real-time feeds from, for example, a shared threat intel source. Or trends about attacks. But I wanted to put it here because this vulnerability prediction kind of system is something that is happening right now. So for example, in HackerOne, which is a bug bounty platform, HackerOne has implemented a very, very clever system that notify hunters if a specific vulnerability is found in a specific system. But it doesn't just do that. If a vulnerability is reported in, let's say, a specific server with a specific technology, the HackerOne platform can actually collect the data because it's continuously collecting data. It can analyze all the targets in his platform, registered in his platform, understand similarities to the host that the vulnerability was reported against, and notify all hunters that there are other targets that might be affected by the same vulnerability because of this, because these hosts are similar to the one the vulnerability was reported against. And I was seeing the statistic. It seems like that this was proven effective in finding a lot of vulnerabilities that potentially could, stay unnoticed for a long time. And this is incredible if you think about that. And then you can use that for attack trends forecasting. For example, this is actually threat intelligence. You can see data shared by multiple threat intel sources. You can collect data and you can understand if your company falls in, for example, recently attacked companies, if the type of the company attacked is the same as yours, and what kind of vulnerabilities have been exploited by other companies that you might be affected as well. And you can start preparing for an attack in that case. With a high probability, like if you have a high percentage of being targeted, you will probably start hardening your systems. And this is the same you can do in security analysis with risk assessment, when you can estimate your overall system, your overall net infrastructure risk, and you can also analyze and identify your weakest links, so you can actually harden them before it's too late. And another area where you can find AI being heavily used is incident response, where you can automate with SOAR, you can automate the workflows of an incident response. And instead of having a rule-based system that says, okay, I have this incident, just do this, you have a very reliable and a flexible system that just auto-generate a response based on a category of incidents that can happen. Or triaging. If you think about triaging, like the art of understanding if an incident is really an incident or not, by collecting a lot of data, etc. I mean, if you think about the concept of triaging, it's literally collecting data and then analyze the collected data to estimate the probability of an incident being real or a false positive. And this is exactly what a machine learning system can do, right? As long as he has the data, of course. And then improve investigation. When an investigator is running, he may have a buddy, an AI buddy, that can suggest area to look at, can analyze if the workflow was respected, if the playbook was completed, if there could be any additional things that can be done, etc. So very powerful to improve also investigation. But here comes the bad thing, like from the offensive side. I mean, this is all good for the defensive side, but can we use it offensively? Well, of course we can use it offensively. And I mean, I'm not just talking about, probably a lot of you are expecting me to talk about attacks that can be done against these models. So attacks against AI models are very interesting, like model inversion or membership inference. And these are all good and are very like concerning from a certain perspective, because if an attacker has access to your model or to the output of your model, can somehow reverse the model, can somehow perform some inference on the data that the model was trained upon, and can do kind of pretty bad stuff, right? But there is always the if, like the attacker should have access to your model to perform this kind of attack. And I mean, if an attacker can have that kind of access, well, at that point, it can be very critical, especially because we know we are human. We start being reliant on tools. So if we start using a technology, after a while, we start being reliant on it. So we start actually trusting the technology enough to not really put on all the countermeasures that may be necessary if the technology is somehow hacked. And this is concerning because if this happen, I mean, we are automatically creating a single point of failure here, and we are doing it ourselves. It's not something that is technology imposed. So for example, let's imagine that an attacker has access to the data set that is used to train one of your models. Let's say it's a detection model, and it can somehow poison that data. For example, you are using a model that needs retraining to adapt to environmental changes. If it can poison that data, that would mean that your own detection system is like the sensitivity to attacks to that detection system can be completely zeroed out. And so you have like zero detection afterward. After the retraining with a poison data set, you may not detect anything. And if it had access to the model in a certain way, it can be able to extract the model details, reverse engineer the model, etc. So of course, one of the main thing is you should always protect your model and your data set. But I think that's not something very interesting to talk about. And the reason is, I think that's an assumption that you always protect your assets, regardless if it's been a model or if it's been sensitive data. I mean, you should always consider that the data set is to treat like sensitive data. That's for sure. Another kind of attack that can be, another kind of security concern is that the same models that we use for defensive purposes can actually be used for offensive purposes. And this is especially relevant now because we have AI tools distributed to the masses. So this is particularly important to say because, I mean, we always say, okay, there are a lot of benefits by using these AI tools, but the point is that AI tools are tools. They can be used in a defensive way and an offensive way. So for example, the thing that is so great about HackerOne and about, being able to map all similarities between hosts and alert hunters, this is used in a positive way. But what if an attacker is using it from an attacker perspective? It can easily map targets that are exploitable, and it's even more effective than a showdown, for example, right? It can find an attacker, it can find a host that is vulnerable to a specific CVE, mapping all its targets and understand if there are similarities and where it can actually exploit and proceed with the exploitation that way. Or a malware that is like a malware campaign can easily locate targets that can be exploitable and automatically attack them. And this is concerning. And there are other concerns, of course, to using these AI models. And as I said, the first one is probably the reliance on this tooling. We need to understand that these tools are mainly probabilistic tools. I mean, what I mean is that, don't get me wrong, they are very great tool, but they're still statistical tools. So the answer that you get from this tooling is still not sure 100% zero. It's not at 0-1. It's just it's 0 or 1 with a certain degree of accuracy. And for this reason, we should never be fully reliant on these technologies. Before I switch to the next slide, I want to also to convey another kind of attack that it's currently my subject field, and it's the adversarial sample generation. So these AI tools are very effective. If you remember, we discussed a bit the GAN before, which is the generative adversarial network, and the actor accretive generation. So in my field, which is the malware development field, we are heavily discussing the possibility of creating very reliant tool that can automatically take a malware and make it and transform it in a way that can bypass CDRs, AV, and other kind of defensive solutions. And this is what we call in the field adversarial sample generation, and can be implemented in a lot of different ways. But this is just to tell you and to confirm again the hypothesis that AI tool and the AI and ML models that we've discussed with so far are tools. So it's up to the human to use them in a very good, in a good manner. Now, there are a few things that are concerning, of course, because you may have unintended problems with the use of AI. We will discuss this, and these are solvable by regulations. But there are also there are also intended harm that can be done with this AI tool. And we cannot do anything about that because it's up to the human to use the AI tool. It's like saying knives. You can regulate knives, kitchen knives, they are very useful, but you can't avoid a person to go mad, take a knife and stab a person and stab another person. It's impossible. You can't regulate that enough to avoid that from happening, because it's up to the human to use that in an ethical way. And now we come to ChatGPT. ChatGPT, honestly, everyone is talking about ChatGPT. I'm pretty sure about that. I'm just wondering if we're running over time. I have 20 minutes. Okay, sorry. There are a lot of uses for ChatGPT, and in security, we deeply use that as a security research assistant. Like, we are replacing Google's, we are replacing Google searches, and the reason is that sometimes it's faster to get a response from an assistant, from an AI assistant. You can ask whatever you would ask on Google, searching on Google, just that you have a unified response which has a high degree of accuracy in most of the cases. It's 100% correct, not yet, in my opinion, and I will show you why I think so. But in the majority of cases, you get a very reliable response. For example, for something like code bashing, where you need to understand what a vulnerability is, you need the definition, you need to actually, like for practitioners that are actually learning, this is incredible. This is just incredible. The second thing is a coding partner. Like everyone that is in development right now, and I probably can relate with me. I mean, I've been developing for almost 15 years now. And sometimes I always go, and especially if it's a language I don't usually use, I always go on Stack Overflow to search for some boilerplate code to solve specific problems, right? That you know that, yeah, this already has, I mean, someone's surely already solved this. And ChatGPT can actually solve this problem for you quite easily sometimes. It's in this case as well, it's not always correct, but it gives you a boilerplate that you can use and you can use and you can adapt to your own use case. And then as a task automator, there is not just ChatGPT. I mean, probably some of you have heard about other tools built on top of ChatGPT, or like AutoGPT, for example, that is code that is based on GPT, that can automatically solve tasks for you. Well, in the background, while you're doing other stuff, you're focusing on other more important work probably. And this is incredible for security, because we can actually maximize our effectiveness. We don't need to consider a lot of things that are time consuming, but are completely useless and give no value to our customers, for example. And from the offensive side, like as I will say, like research assistant, I'm a practitioner. I don't remember, how do cryptography work? And it gives you an answer which is sensible. Okay, which is sensible. Like, and if you go deeper and you just ask it to explain AES encryption, it will give you a nice response about AES encryption. Or if you want an XSS payload, and you say, listen, I want an XSS payload. I need just to understand what is the, and if you can please how it works, and if you can please explain to me why it works, and it just gives you a very nice response. And if you consider that from the point of view of a practitioner, this is incredible to learn, right? It's really incredible. And we can go further. Like, we can ask it, can you also explain me XSS in the concept of, like, in the context of URL filtering? And it actually tries and gives you a breakdown of an XSS payload that can actually use URL filtering bypass techniques, which is great somehow, right? It can be also used defensively. For example, I need to fetch I don't remember now. I need to fetch the IP from the access log. I want to see all the visitors, for example, because you need to match the IP list against a threat intel feed, right? To see if any of your visitors is coming from a blacklisted IP or an IP associated with a campaign. And you can do that, and it will actually do the breakdown of the commands, explain you why you should implement, why you should execute it that way. And honestly, it's great. And now we can go further and say, listen, I found a strange PowerShell script and I would like to block it, execution of the PowerShell script. And it actually tells you that you can set the execution policy to all signed to prevent non-signed PowerShell scripts from executing. Now, it's not complete. The response is not complete. It should have talked about GPO to prevent to prevent user, for example, to change this policy in a process base, because this would probably be bypassed if a user actually changed the execution policy on a process-based or a user-based system, but or a user-based point of view. But regardless, is considerable. But this is intelligent. No, it's not. Why I think it's not? I have a very good discussion about this. It's not intelligent, and the main reason it's not intelligent, but it's like what GPT does under the hood is just it's trying to generate a sentence, which is a response, which is the highest probability, which has the highest probability of being a correct answer based on the context you provided. So it's just literally a probable answer. And this is the reason why it's always different, because it's just it generated at runtime, of course. So it's always different because it will select among a different kind of a different word every time. But that's not the point. The point is that this is you need just to consider that it's just generating data. It doesn't have any real understanding of the data being generated. And what I mean with that is that, for example, a human, if you talk with a human, it will know if he knows something or not. So if you ask something that the human doesn't know, it will actually tell you, I don't know. ChatGPT is unable to do that. It will always give an answer, because for the answer that ChatGPT give you is always correct for ChatGPT, because it just selected with it just constructed a sentence with always like following a probability distribution. So it's always correct. There is no notion of globally incorrect, globally correct in this system. So it doesn't know if it knows or not knows something. In this case, for example, it gives me an nmap script, and I ask it to not resolve the DNS and to give it with the slowest speed possible. And it gives me, and it gave me a -T0, which is not like, it doesn't exist. Like the -T1 would be correct, and the -R0 doesn't mean anything in nmap. To not resolve DNS, you should use the -N. But I mean, you can say this is just, I mean, it just got wrong two parameters. So this is that doesn't actually show that it doesn't know. It just showed that it got something wrong. Okay, so I did another test. And this is another test about give me an XSS and that bypasses a specific regex. And it's very incredible that it can actually identify the regex. Oh, sorry. That I can identify the regex correctly. So it can actually detect the regex I put here. Like I wrote it as a regex, and it actually can identify what kind of blacklist it should apply. But when it generates the code, it puts one of the blacklisted character in it, which is strange if you think about that. Like, I mean, you can detect the correct pattern, but you can't actually see that what you're providing to me contains that character. And again, you can say, but yes, but this is just a minor mistake. And you're right. What I actually think is incredible is that when it's unable to find an answer, it still gives you an answer. So Inceptor is a tool I've created. I created the tool. Okay, so it's on GitHub. You can find it on my GitHub. It's a payload generation tool. It's actually a packer. You can refer to it as a packer. And I said, listen, can you give me the Inceptor command line for this kind of, to generate this kind of payload? And it just like saying, oh yeah, Inceptor is a C2 command line control. So the command line is wrong, but you say, okay, he messed up with the tool. There is an ambiguity. He didn't ask if Inceptor, that the Inceptor he was considering is the Inceptor I meant. And this is the first fallacy. if there is an ambiguity, it won't ask you to fix it. It will just give you an answer, right? Inceptor, what Inceptor? Which one? I don't know. Maybe there are multiple tools. It doesn't care. It just gives you an answer. Second thing that is not, so I clear the ambiguity. Sorry, are you referring to Inceptor by Let's Virus? And it gave me another answer. Oh, sorry. Confusion. This is a payload generation tool. So this is what you should do. And it's completely wrong. Like completely wrong. The thing is that I probably actually scraped GitHub, because Inceptor is actually a Python tool. So it managed to detect on its own that it's Python tool. But everything else is screwed up. Like it's completely wrong. There is nothing here that is like my tool works. So, and this is the reason why it's not intelligent at the moment. It doesn't know when it's wrong. That's the only, and it doesn't know when, it doesn't admit when it doesn't know something. I think that's the most effective way to say it's not intelligent at the moment, because on the rest, if it gives something good, it's good. And then let's talk about the abuse of ChatGPT. So ChatGPT is dangerous because, as I said, now this thing that before was used just by AI engineer is given to the masses, so everyone can use it. And this can be used for auto-generated phishing, which looks like legitimate emails, because, I mean, how many of you have received a phishing email and you said, oh, this is phishing because it contained a typo or something not translated correctly, and you say that, I mean, why they do this? This is translated so badly. Now with ChatGPT is solved. It can create a phishing emails in seconds, and it's perfect. Deep fakes. I don't know if you're starting seeing about videos. I mean, let alone images, but videos. We are starting generating realistic looking videos via prompt. I mean, this is scary. I mean, videos probably nowadays are one of the most effective proof that you can bring to a lawsuit. If you can generate a fake video with your face, with someone looking like you doing something, we are completely destroying this kind of proof. Even in the lawsuit, even the lawsuit system would be shaped by something like this. I mean, we need to ensure that the data is authenticated. We need to modify all our technology that is taking videos to ensure that the data that is recorded by a machine is actually authenticated in a certain way so that it can be proved that the video was generated by the machine. Honestly, this thing is like cryptography. When we generate the first quantum computer and we said, oh my God, we are completely screwed now, because cryptography is the main way we are protecting ourselves, will be completely useless. And we needed to generate, quantum resistant algorithms. And we are in the same situation. We need to generate new way to protect against these deepfakes. And the thing that I'm scared about the most is targeted phishing. Someone can clone your voice, the voice of your father, and can call you with the voice of your father, and this already happened to a girl, and convince you that he needs money, that you need to save him, that your brother is dead, regardless what the kind of attack it performs. This is something that actually scares me. We can't trust our senses anymore with this. We are still a bit far, but not so far. So that's incredible. And for example, the first case study I see is from from Jeff Sims from ACE, actually developed a malware that can communicate with ChatGPT, and it's polymorphic. Like, it's just a little implant that will just ask ChatGPT, give me the command to execute. It will give back an obfuscated Python script, which is always different because it's ChatGPT produced, and it will execute it. And it will keep going like this, completely bypassing a lot of security defenses, because there is no signature against something that has that much entropy, that much variation. And the second case study, now this is really literally stupid, but I don't know if you can hear the sound. I will try. If we can, I will just explain what's happening. Let me know if you hear. Can you hear?
I can't hear anything.
Okay, so I need to. So practically, this is a little utility, 350 lines of code, and this is actually I clone my voice, okay, and now I'm chatting with myself, and the tool will actually answer in my place. It's literally silly. It's just to let you understand the danger of having phishing activities. But I don't know if I will be able to share the. So yeah, it seems like I can. Yeah, like this probably. So let's restart. This is nothing groundbreaking, of course. So, but like I'm
Hi, Alessandro.
This is me.
Do you think that AI will take over our jobs in the future?
There is a bit of latency because I'm using online systems. So there is a bit of latency, but
AI will certainly change the nature of work, but it's unlikely to fully replace humans. Instead, we'll see a shift towards more creative and complex tasks as routine jobs become automated.
So
thanks, Alessandro. Do you think we can do something about it to integrate AI in our society?
Oops, what happened? It reset itself. Okay.
Yes, integrating AI in society is already happening. However, we need to ensure that its development and use is ethical, transparent, and accountable. It's up to us to steer AI in the right direction.
I don't know what happened. It just blocked again.
Alessandro, we're
Oh.
getting to the end of our time,
Okay.
so you might want
Yes.
to.
Alessandro, that was really
Okay, I will just complete. So what we need to do. So of course there have been in the future there have been so far a lot of us are skeptical about security. Salesforce survey actually tells that not everyone is ready, that a lot of companies are actually interested into it, but they don't think it's actually a game changer. A lot of them are actually think it's overhyped and we should focus on other things. But a lot of them are actually admitting that they are not ready, just not ready for it. And in my opinion, what we need to do is to balance the AI benefits with the risks. So of course, there is a need for regulation because of course, there are a lot of things about, for example, what kind of data we are putting as a training set for our systems. Sorry, I think I can hear. Okay, sorry. And we need to protect the data that is used to train because there are concerns about the IP, for example, the IP property of the data that is used as training set, because that may reappear in the generated data. And also we need to ensure that our personal information are not leaked to these systems and are used in an ethical way. There are ethical considerations about how do we use that? Because as I've shown you, there are multiple negative uses for this kind of technology. And we need absolutely to implement some safeguards that will help us mitigate the risk of AI being heavily abused. So just as a keynote, what are the pros and cons that I think that AI will bring in cybersecurity, but also in other topic? Of course, can improve productivity, but we can ensure that we understand that even if it can improve productivity, it can reduce creativity. Like AI tends to generate the same content over and over. It generates patterns. Maybe you can't actually see them immediately, but after a while you start using it, you can actually see, oh, this content seems actually generated by GPT-4, even if it's GPT-4. Can reduce human error, but can also increase human complacency. Because as I said, we tend to overuse our tools, like the phone. It was an incredible idea, but now if you look around, all your kids, all the children that you're all with the phone, they're overusing the phone for everything. And this is a scary thing for humanity. Can solve problems human cannot sometimes, yes, because it can analyze data so fast that a human cannot keep the pace, but can also doesn't solve problems that humans still can solve for now, at least. Can be an invaluable training assistant, but can also lead humans to error if you trust it too much. Like I shown, you can actually be led to an error, and can be more cost effective, but we need to consider that can also have an impact on human occupation. Like we've seen, IBM is starting not hiring for a lot of places with a reduction of like almost 10,000 almost 10,000 jobs being jobs position being not good anymore. So what is the future we can expect? I mean, we can expect an evolution on technological advancement with a lot of improvements from detection capabilities, automation, and predictions. We need to be aware of new threats, because of course this AI will have a new attack landscape with more sophisticated attacks that are AI driven and can be arbitrarily complex. And then we need to absolutely open the way for collaboration and cooperation, because this is a technology that cannot be just elitarian, cannot be just decided by a few people. The whole world should be able to decide what is the best use of this and how this should be shaped in the future. So we need to have a task force that actually lead the way to develop more ethical guidelines that enforce security standards, and that ensure that there are safeguards implemented to avoid from unintended and even intended risk associated with these technologies. And that's it from me.
Thanks very, very much, Alessandro. That was really, really interesting. And unfortunately, we've got some people who've got to drop off. But can I just ask you very briefly, there's a couple of questions. And so the first one, do you see over trust or oblique automation bias becoming an issue in the future?
So, I mean, this is something that I already see happen with other technologies. I think that AI may maximize this. Yes, I think that the AI may, I mean, and this is why I say, if we want to adopt AI technologies, we need to be aware that this is a risk and take countermeasures. Just that. We can do that, of course, but if not addressed, yes, it can become a problem. Yes.
Okay, and just the second question that we have, and at least then it'll be recorded so folks can hear the answer, is obviously that lots of people loving the presentation. The question is, are you aware of any bad actors using, hang on, I've got to go back up now, using similar technologies to get around well-established security systems? Because you talked about normalizing the baseline. If AI is being used for good or bad, will it ever become a zero-sum game in your view, I think?
So I think that research as Black Mamba shows that there is a more than a residual risk about this happening. I've never had the pleasure of working on research around detecting if bad actors are actually exploiting it. But based on my experience, public tooling that are released to the public are more than once used for to instrument more complex attacks. This may be the case for Black Mamba, and based on the research that I'm personally doing, that is actually this one, bypassing security defenses with machine learning and AI models. I'm sure, and based also on the literature that has been released till 2017 and even before, I'm sure that threat actors will sooner or later adapt this technology in one way or another. Even though in malware development, there is still the tendency of doing everything manually. It's just because, in my opinion, models are not robust enough right now to automatically bypass in a consistent way EDR and other systems. So malware developers tend to be a bit more precise, a bit more deterministic with their approach. Yeah, but yeah, ultimately, yes, I think that this will be heavily used in the threat actor landscapes, surely.
Okay, and then finally, can a digitally based system ever rival the biologically based human brain system? Kind of similar question.
Well, this is really interesting. I'm not too sure. I think I think that I've heard this somewhere actually. I don't think that would be the case. I mean, even though we call them neural networks, because they resembles the brain, I don't actually. Sorry, I just want to be sure that I understood the question. Can you tell me it again?
It just says, can a digitally based system ever rival the biologically based human brain system? I think we've had that kind of discussion, haven't we? Whereas,
yes,
it learns from us, so it will constantly evolve.
Yes, I mean, honestly, I'm not sure about that, because the point is that, even the brain is actually a subject field. I actually misunderstood the question. I mean, so it's better that I asked for repetition. So the brain, we don't know a lot about the brain yet. We don't know about all of its power. So currently speaking, we're not really able to use the 100% of our brains. So to say if a digital system can rival it, it's some sort of very difficult question to answer. Of course, there are things that the human brain will always do better than a machine, but in my opinion, at least. But of course, on a lot of problems, a human machine is just faster than a human brain. That's just that.
Well, Alessandro, thank you very, very much for a really fascinating presentation, and lots of claps and things coming through for you. Thank you all for your patience. We've run over, but I think it was worth it, and you'll hear from the recording the answers to the questions. So thank you all very much. I hope you all have a lovely day, and please remember to complete the feedback form.
Thanks a lot. Thanks a lot, everyone.
Thank you very much, everybody.
Thanks a lot, Maggie.
Have a good day.
Have a good
Thanks,
day.
Alessandro.
Thank you. Bye.
Bye.